Okay, so this particular problem deals with vector addition and subtraction. So, okay, let's go through this. So, a ship moves along the equator, okay, to the east. There's a direction with velocity of 3 v naught equal to 30 kilometers per hour. The southeastern wind, so there's a small catch here which we'll be discussing later. Now let's go through the question. Blows at an angle of phi equal to 60 degrees to the equator with velocity v equal to 15 km per hour. Find the velocity, wind velocity v dash relative to the ship and the angle phi dash between the equator and the wind direction in the reference frame fixed to the ship. Okay, so we have to find out everything with respect to the ship. Okay, one catch over here is, so I'll just write it down. So whenever we talk about wind direction, you can Google this. So it essentially is the direction from which the wind originates. This is a very important point. So basically, if it is a southeastern wind, let's take a simpler example. If it is a northern wind, then it originates from the north. That is, it goes from north to south, towards the south. It basically goes. Similarly, if we consider the southeastern wind, so southeastern wind is basically it originates at the southeast direction, which means that it goes towards the opposite direction. Its flow direction would be basically northwest in that case. Okay, so now that that's clear, let's make the vectors now. Let's draw the vectors. So the ship velocity is v naught. So this is the ship velocity. Okay, first of all, I'm considering this to be north, east, and of course this will be south, this would be west. So ship is going the east direction with a velocity of v naught. So since this is a vector, so this vector, okay, now the wind is southeastern wind. Okay, so southeastern wind is basically, it originates in this particular area, right, somewhere here in the southeastern direction. And since obviously this is your equator, right, southeastern will be somewhere south of here. So in general, let's not worry about the equator for now. That is immaterial because we are just considering the direction, doesn't matter. So what we want is something that originates from the southeast, is basically the direction will be towards the northwest. So it will be something in this direction. So that will be your V. So yeah, so ignore the point about the equator that I just said. It is not important. What is important is, it is a southeastern wind, it originates from the southeast, and hence it goes towards the opposite direction, which is the northwest. Now the angle between the equator and the wind direction, the angle between the wind and the ship is essentially this angle, right? So this angle is basically phi, right? So yeah, that's the angle. So now what we need to do is we need to find the velocity of the wind with respect to the ship. So that would be v vector subtraction minus v naught. So we need the magnitude of that. So v dash is basically the magnitude, so it will be like mod of these two. Okay, simple. So for that, what we need to do is So we basically are adding v and minus v naught, right? Alright, so now this figure can also be drawn as like this. This is v. This equal and opposite is minus v naught, and of course this is again phi. Alright, so we are basically adding these two vectors, and we know, or else it's not required. Okay, there is a formula for vector addition, but I'll just like take the components of the vectors in two perpendicular directions and basically like square root of the squares of the magnitudes in the two directions will give me the resultant magnitude. So basically this v has two magnitudes. One is, so this I'll again, so this can be, so this is basically in this direction. I will just write the magnitudes here. So in this direction it is v cos phi, and obviously since minus v naught is in this direction, so it will get added up. So basically it will be plus v naught, and in the upper direction it is v sin phi. Okay, now so these are the two components, so the resultant magnitude will be the square root of sum of the squares. Square root of v cos phi plus v naught whole square plus v sin phi whole square. Okay, if we square this, becomes v square cos square phi plus v naught square plus 2 times v cos phi times v naught v square sin square phi. This becomes, yeah, so this becomes essentially v naught square, v square, so cos square phi and sin square phi, v square comes out as common and cos square phi plus sin square phi becomes 1 plus 2 into v naught into v into cos phi. So this is in terms of v naught and phi. So this is your v dash. You can substitute the values and get the answer. So, but we'll do it. I guess we'll do it anyways. So we see v naught, it is 30 and v is 15. So 30 square thirty square plus 15 square plus 2 into 30 into 15 into cos phi. So what is cos phi? Cos phi is cos 60 degrees, and as we know cos 60 is half, so 2 cancels out. This becomes 900 plus 225 plus 450. This becomes 1575, which is approximately 40 kilometers an hour. This is also given in the Irodov solution or Irodov answers. Alright, and also the angle phi dash. Alright, so angle phi dash also is very easily found out. So it's with respect to the ship, what is the direction of the velocity of the wind. So that will basically be the resultant, the direction in which the resultant is. So it will be basically this direction, right? Okay, they are asking with respect to the equator, so yeah, this is basically your phi dash. So it essentially becomes tan inverse the, because yeah, so it becomes tan inverse v sin phi by v cos phi plus v naught, v sin phi by plus v naught, right? Okay, So yeah, you just need to feed in the values and see like the tan inverse of that. I'm not calculating this, I'm leaving it here, you can check it out. So yeah, that was the solution for problem 1.6. So thank you.